Hello, beautiful people, and welcome. In today's video, we are going through the Chapter 5, Are You Ready packet. This is going to be your homework assignment for our Chapter 5 exam. Let's go ahead and get started. In Semester 1, we talked about solving systems. We talked about solving system elimination, substitution, and graphing. So this is going to be from Semester 1 that is carrying over into Semester 2 that, yes, will be on our Chapter 5 exam. For elimination, we are going to be choosing a variable to eliminate. So you can choose either the x or the y, but they have to be lined up. So in question number 1, I am going to be choosing this positive 7y and this negative 7y to eliminate. Why am I choosing my y's? Well, first of all, they're both 7. Here's 7 and here's 7. But also I have a positive and a negative, which means to eliminate, I'm going to draw a line here, and I'm going to add all of my terms vertically. So I'm going to do a little dotted line for my equals. So what ends up happening is I'm going to have a negative 7x plus 6x, a positive 7y minus 7y, and here I have a 14 and a negative 5. And so with our elimination, we're going to eliminate the variable of our choosing. So 7y's and negative 7y's, this is going to be removed or eliminate. Now here we have a negative 7x plus 6x's. That gives me a negative 1x. Let's extend our dotted line. And here on the other side, we have 14 plus a negative 5, which gives me a positive 9. Now we are not done here. We do need to remove this negative in front of x. So I'm going to divide by negative 1 on both sides. Remove the negative 1. So we got x is equal to a negative 9. Put that in a thinking bubble because this is not your answer. Remember, this is not your answer. This is just part of it. We're going to then choose one of our originals. It really doesn't matter which one you choose. I'm going to choose the top equation. Just pick one. It doesn't matter. I'm going to write it out, and I'm going to open up for x. The reason I am opening up for x is because I just solved for that value. So I'm taking this negative 9, and I'm going to put it into the x value. Now, if you are using a calculator, please be careful with your operations. This is going to be a multiplication, not a subtraction, even though it comes with a minus. So to type this into the calculator, you're going to do a negative 7 times a negative 9. And it should look something like this if you are looking at a calculator. So you would do negative, well, let's make sure you guys can see that. Negative 7, you could do times like this, open negative 9. Or you can remove the little time symbol and just have negative 7, open negative 9, close it. Make sure the parentheses are there. That is super duper important. And we got 63. So let's go ahead and draw an arrow. 63 plus, bring down the 7y, equals 14. Now I'm going to draw a dotted line for a balance. That's what the dotted line represents. And now we're going to be subtracting 63 on both sides. 14 minus 63, I get 49. Let's remove the 63s, bring down the positive 7 times y. Divide by that positive 7. We got negative 49 divided by a positive 7. Y is then equal to a negative 7. Put that in a thinking bubble because remember, this is not the answer. So that's not the answer. That's not the other. So what is the answer? The answer is going to be the combination of both. To write the answer, I'm going to create a little answer box here. We're going to open up with parentheses, close the parentheses. Our x was a negative 9. Our y was a negative 7. So our answer is going to be open negative 9, comma, negative 7, close it. Moving on to B. Same thing, it's still in that same category. We are going to be removing by, or excuse me, solving by elimination. So let's go ahead and choose a variable to eliminate. So I can choose either the x's to eliminate, I can choose the y's. But notice 4 and 3, they're not the same number. 12 and 6 are not the same number. But which one looks like it's easier to eliminate? 4 and 3, yes, they do have something in common, 12. But if I do 12 and 6, I only need to multiply one of them. So I'm going to choose 12 and 6. So I'm going to choose the letter Y to eliminate. So positive 12, positive 6. Y is my choosing. So that means I'm going to select this bottom one to kind of work with first. And I'm going to make a positive 6y into a negative 12y by multiplying all terms by a negative 2. Okay, so what does that look like? That looks like if I pick up my negative 3x plus 6y is equal to 21, and I'm going to times everything by a negative 2. See if I can make this a little bit darker so you can see. What does that end up? Well, negative negative is a positive. 3 times 2 is 6. So we get a positive 6x. Negative positive gives me a negative. 6 times 2 is 12y. So that's kind of the point. We wanted to make this 12y equals negative positive is a negative. 21 times 2 is 42. This right here, I'm going to put this one in a thinking bubble. I will highlight that in just a moment, is what I'm going to use with the original, the one that's on top. So take the original of negative 4x plus 12y is equal to 24. Take the one that you just worked with. This one here, this is the one that you created. We're going to bring that under the one that we did not touch. So the one that we did not touch is that negative 4. And then the one that we created is now this positive 6. So we write positive 6 x minus 12y is equal to negative 42. Okay, so what was the point of what we just did? Well, the point of what we just did is to eliminate this positive 12. And now we have a negative 12 on the y. So we can now do what we did in our first example and add vertically. Here's my dotted line for balance. And our goal was to remove y. So go ahead and eliminate y. Add vertically. So we would type this into the calculator if you are using a calculator. Negative 4 plus a positive 6. I get a positive 2x's. We have now removed y, 24 and a negative 42. And I get a negative 18. Don't forget, this is now multiplication with 2 times x. We need to remove that 2 by dividing by 2 both sides. Remove the 2's, x is then equal to a negative 9. Put that in a thinking bubble because that is not your answer. Just like we did before, we're going to choose one of the originals. It doesn't matter which one you choose. You can choose the pink here that we did not touch. You can choose the purple here that we did touch. And then this one here, the one that we created, the blue, you can also use that. It doesn't matter. I'm going to choose the original purple just because it's closest and I have space here. We're going to open up for x. We're going to put in our x of negative 9. Now remember, this again is calculator or your brain, but this is not subtraction, this is multiplication. So negative 3 times negative 9 like this. Or you can do negative 3, open, negative 9. This is also multiplication. We get 27. Bring down the 6y, bring down the 21, dotted line for balance. Subtracting the 27 on both sides. Remove the 27, bring down the positive 6 times y. Here we have 21 minus 27, which is a negative 6. Divide by a positive 6 both sides. And on one side, our goal is to remove. On the other side, our goal is to divide. Negative 6 divided by 6 is a negative 1. Again, thinking bubble, that is not your answer. So what is the answer? Let's create our answer box. And again, the reason we math teachers like answer boxes is because when we're grading your test, when we're grading things or your homework or your whatever, we actually can't find your answers. So go ahead and put them in a box so we can actually find them. It's a lot easier for my eyeballs to see what you want me to see when it's in a box. And we have our answer for B. All right, let's go ahead and move on with C. Let's take a look. We have 8 and negative 3 on our x's. We have negative 4 and 3 on our y, negative 3 on our y's. Again, I'm not really looking at these constants. These numbers really don't matter. So I'm looking at our x's. What can make these the same? Or I'm looking at our y's and I'm making what can make these the same. So again, I'm going to choose on the y's. You absolutely, it looks like I chose y every single time. It really doesn't matter. Choose whatever you want, either the x's or the y, but you have to make them look the same. So if I am choosing y's, that means I need to make 4 into a 12, and I need to make negative 3 into a 12. So I need both of them. Now, one of them needs to stay negative. One of them needs to be changed into a positive. So what I'm going to do is I'm actually going to cheat a little bit, and I am going to erase, here's my whiteout, this letter C. I'm just going to remove it. And the reason I want to do that is I'm going to, well, first of all, I'm short on space, but I'm going to multiply times this top equation by a positive 3. So I'm going to do positive 3 times 8, positive 3 times negative 4, and a positive 3 times negative 12. That's what I'm going to do on the top equation. Now, on the bottom equation, I'm going to be multiplying by a negative 4. The reason I'm choosing a negative number here, a negative 4, is because I'm going to want to create a positive on this 3. If the symbols are opposite, then I can just proceed by adding. Okay, so what does that give us? Use a calculator if you need to. We got 8 times 3, which gives us a 24x. Negative 4 times 3, we got a negative 12y. Negative 12 times 3, we get a negative 36. So that's my top equation. Now for my bottom equation, I get negative 4 times negative 3, which gives us a positive 12. X's, almost forgot my x's, negative 4 times a negative 3, we get a positive 12y, and a negative 4 times negative 27, oh, big number, 108. Now that we are looking at our y's, so here's y negative, here's y positive, opposite signs, same numbers. Let's go ahead and add vertically. Here's my dotted line for balance. Always put in your dotted line for balance. Okay, 24 and 12 gives me 36 x's. Our goal with our y's was to remove negative 36 and 108 gives me 72. Again, you're not done. There is a secret multiplication dot here. Mathematicians are lazy, so you won't see sometimes this multiplication, but it is there. We're going to divide the 36. Remember, on one side, our goal is to remove. On the other side, our goal is to divide. So we have 2. Remember, thinking bubble, because this is not your answer. Now to find y, we're going to pick up, you can pick up one of the originals or you can pick up one of the ones that you created. I usually go with the original. So I'm going to pick up the original. Let's say I'm going to choose this one here. So we got 8 open for x minus 4y is equal to negative 12. Now our x value was a positive 2. I'm going to put that positive 2 in. And again, this is calculator or your brain. Remember, this is multiplication. If it helps, put in that multiplication dot. We got 8 open, 2, close it. So we got here 16 minus 4y is equal to a negative 12. So then I'm going to remove the 16, dotted line for balance, remove the 16. So we got negative 12 minus 16. We got negative 28. Bring down the negative 4 times y. Be careful with the negative. Divide by negative 4 both sides. Reminder that on one side our goal is to remove. However, on the other side, our goal is to divide. So negative 28 divided by negative 4, I get a positive 7. Put that in a thinking bubble because that is not our answer. For our answer, we're going to draw a little answer box. And we're going to write in our answer. So we got open 2 and 7. So open 2, comma 7. And then close the parentheses. Alrighty, that was elimination. Moving on. Next up, we have substitution. Substitution is exactly what it sounds like. We're going to substitute or replace things. When we have a y equals and a y equals, we're going to set our two equations equal to each other. So I'm going to pick up this top negative 8x minus 13. And I'm going to pick up this bottom of 2x plus 7. And you can only do this when it's both y equals. Again, only do this when it's both y equals. So I get negative 8x minus 13 equals 2x plus 7. Set them equal to each other, dotted line. And now we are solving like we do typical equations in semester 1. I'm going to go ahead and remove that 2. Actually, I'm going to change my mind. I'm going to remove 8. I'm going to add 8 to both sides, 8x's. Again, on one side, my goal is to remove, bring down the negative 13. Here, my goal is 8, 9, 10 to add, bring down the 7. Again, my goal is solving, so I'm going to remove the 7 by subtracting 7. Bring down the 10 times x, dotted line for balance. Negative 13 minus 7, I get a negative 20. Divide by 10, divide by 10. On one side, our goal is to remove. On the other side, our goal is to divide. Negative 20 divided by 10 is a negative 2. Remember, this is not your answer. Now, to find y, you're going to pick up one of your originals. So I'm going to choose this bottom one because it's on the bottom. It doesn't matter. And I am going to open up for x to put in the value of negative 2. Now, this section, all of it, you can type into the calculator, pressing enter once, and you will get your y value. Now, when you type this into the calculator, you want to type it in exactly how you see it. So 2, let's see if I can move this. There we go. 2, open, negative 2, close, plus 7, and it gives you 3. Let's go ahead and write our answer box. So open up, negative 2, comma 3, close it. Now notice the difference between A and B. A has 2 y equals. B only has 1 y equals. When that happens, you're going to pick up your equation, the one that is not y equals, all of it. I'm going to now write it out, opening up for y. So 2x plus 6, big open, equals 4. And the reason we want to do a big open is I'm going to pick up this negative 2x minus 11, and I'm going to put that into my open spot for y. Negative 2x minus 11. What makes this kind of like a level 2 question is this is 6 positive times negative 2 times negative 11. So that means we are going to be using a distributive property to distribute that positive 6. That means we have 2x. This is a positive 6, so positive 6 times negative 2 is a negative 12 x's. positive 6 times a negative 11 is a negative 66, and that's equal to 4. Combining like terms, dotted line. We have 2x's minus 12x's. That gives me a negative 10x. And then we're going to add 66 to both sides. So we get negative 10x's minus 66. Add 66 to both sides. Remove, bring down. And so we have now the 4 plus 66, which is 70. Again, divide negative 10. Divide negative 10 on one side. Our goal is to remove. On the other side, our goal is to divide. Zeros go away. 7 divided by negative 1 is negative 7. Thinking bubble, because this is not our answer. So now we're going to solve for y. To pick up for y, we're going to choose the equation that is the y equals. You only want to choose the one with y equals because it's easier. You can use a calculator, type everything in. Y equals, now we're opening up for x. We have our x value, and our x value is negative 7. Reminder, when you're doing this, you are multiplying, so this is a times. Calculator, if you're using a calculator, type it in exactly how you see it. Negative 2, open negative 7, close it. That gives me a 14 positive minus 11. Now, you do not need to split this up. You can type this in all at once. I just wanted to show you that. So to type this in, I'm going to cover this up. Typing this in all at once, we get negative 2, open negative 7, close it, minus 11. And then we can just get our answer again. But this is not our answer. Our temporary, our partial. So let's go ahead and write out our answer in our answer box. Open negative 7, close it, positive 3. Okay, last one for substitution. We got 2x minus 8y is equal to 20, and we got negative 4x plus 4y is equal to 8. Now, some of you are going to be tempted to use elimination, but you can't. You cannot use elimination here. Why? Well, because it's not asking you to. It's asking you to use substitution. So what we're going to do is we're going to pick one. It doesn't matter. I'm going to choose the bottom one. You're going to solve for y. So kind of making it look like this b, I'm going to make the bottom one into a y equals. I'm going to keep the top one the same. So what's going to happen is on this top one, I'm going to replace and open for y. And on the bottom one, I'm going to solve for y. So what that looks like on the bottom is I'm going to pick up the entire equation. Negative 4x plus 4y is equal to 8. We want y by itself, so I'm going to do a literal equation by literally moving things around. I'm going to bring down the positive 4 times y. Here I have 4x plus 8. It's a positive 8. Dividing by 4, every single thing. It's not just 1 divided by 4, it's all divided by 4. That means y is equal to 4 divided by 4 is 1x. 8 divided by 4 is 2. Put that in a thinking bubble because that is what we're going to be using for our y. Let's pick up that top equation. I'm going to copy it down and I'm going to open for y. We have 2x minus 8, big open for y, equals 20. Now for our y, we had x plus 2. Reminder, what makes these questions a little bit more challenging is that we're going to need to distribute this negative 8 onto x and onto a positive 2. We're left with 2x. Negative 8 times x is a negative 8x. Negative 8 times a positive 2 is a negative 16. Okay, combining like terms, we got 2 minus 8, which is a negative 6x. dotted line, here's 20. Add 16 to both sides. Bring down the negative 6 times x. Dotted line for balance. 20 plus 16 is a 36. Divide by negative 6. Divide by negative 6. X is then equal to negative 6. Put a thinking bubble. Now remember, you did not solve for y yet. When you solved for y, we still had an equation. So this very last step is you're going to pick up this x. You're going to bring this x back to your y equals equation. Then you're going to open up for x. Putting in our x value of negative 6. Now, since we already have a y equals, I can just type this into the calculator and get negative 6 plus 2, which is a negative 4. Now that we have both our x and our y values, we can go ahead and write our answer box. Writing out our answer of open negative 6, comma, negative 4, close it. Okay, next up we have is graphing. Now there are two styles of equations that you need to know for chapter 5. The first one is going to be your slope-intercept form, your y equals mx plus b, and the next one is going to be your standard form. Let's go ahead and start with the first one. We're going to graph. Now remember, in y equals mx plus b, I'm trying to figure out where to write that. Let's write that on top. Y equals mx plus b. This is going to be your start value. This is your y-intercept. Oops. Y-intercept. And it's going to be 0, comma, whatever this b value is. Now on the other one, we got m, just the m. M is your slope. If your slope is positive, you are increasing. If your slope is negative, you are decreasing. So here, let's do our first one. We got a start at negative 3, 0, negative 3. We got our slope at negative 1/4. So negative means we're going to go down. And 4 is to the right. I'm going to switch to pencil just in case. So let's find a negative 3 on our y. Then we're going to go down 1 to the 4, 1, 2, 3, 4 to the right. Down 1, 1, 2, 3, 4. Down 1, 1, 2, 3, 4. Be careful on the graphing, especially here. It's really difficult to see. Now that we have our pattern, we can go to the other side. So up 1, 1, 2, 3, 4 to the left. Up 1, 1, 2, 3, oops. 1, 2, 3, 4. Up 1, 1, 2, 3, 4. There it is. Okay. Pick up a ruler, straight edge, and you're going to go put your ruler under, a little bit under your lines. Not your lines, your points, and then you're going to graph. Now these ones here on the graphing, you want to extend your line past your x and y axes. So that's going to be the first one. Let's try to color code this. So this is your top one. Okay, let's do the same thing for the bottom. We have a start at 0, comma 1, positive 1. And our slope is also negative, so we're still going to be going down. And it's down because of this negative, and then always to the right. You can always go to the up and to the left as well, as you can see here in just a moment. So we're starting at 1. Let's use pencil just in case. Positive 1. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Now the other way. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Here we are. Pick up your ruler and connect. Now, what we are looking for in our graphing of systems is we're looking for an intersection between the two given lines. And that point of intersection is going to be our answer. We're looking for an x value. We're looking for a y value. So I'm going to take my intersection. I'm going to drag up. That's going to be my x. And I'm going to drag to the side. That's going to be my y. So our answer, here's my little answer box, is going to be open x is positive 4, comma, negative 4 on the y. So again, we're looking for the answer is our point of intersection. All right, let's go again. Notice for B that I do not have a y equals. These are in standard form, so you have a choice to make. You can either solve using your x and y intercepts, or you can just solve for y and then use your mx plus b format. So I'm going to choose to solve for y. I'm going to create a little t-table. I'm going to solve 3x minus 2y equals negative 8, and I'm going to do x minus 4y is equal to 4. Now again, here, my goal is just to get y by itself. I'm going to remove 3x by subtracting negative 2 times y is equal to negative 3x minus 8. Divide by negative 2. And when you're dividing by this negative 2, every single thing gets divided by negative 2 on this side. So we get y is equal to negative is a positive 3/2 x. Make sure x is in the middle. Negative gives me a positive 4 divided by 2. Sorry, 8 divided by 2 is 4. Put that in a thinking bubble. This is going to be your first line equation. Same thing on the other one. Our goal is to solve for y. So I'm going to remove x's by subtracting x on both sides. Dotted line for balance. Bring down the negative 4 times y. We get negative x plus 4 on the other side. Divide by negative 4 every single thing. Now be careful here on the divided by negative 4. Negative is in fact a positive. 4 stays on the bottom. X gets moved in the middle. And I'll talk about what goes on top. Negative positive. So positive negative gives me a negative. 4 divided by 4 is 1. Now let's go back to what number is in front of x. Now remember, mathematicians are lazy. So if we can not write something, we're not going to do it. So like multiplication symbols or numbers in front of x's. Well, how many x's do I have? I see 1x, so that means I have to put in a 1 as a placeholder in the numerator. So here's our second equation of the line. Alrighty, so let's go ahead and identify our starts and our slopes. So for this one, we have a start at 0, 4, and we have a positive slope. That means we're going to be going up 3 and to the right 2. I'm going to switch pencil so I don't make mistakes. Here's 4. Here's our start at 4. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2. Oop, ran out of space, so now we're going downhill. 1, 2, 3, 1, 2. Following the pattern. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Because we're looking for the point of intersection, we want to create as many points as we can. Okay, and then when we graph the line, when we use a ruler, we want to extend the ruler past or extend the line past the given x and y axes. Okay, so that's going to be our line number 1. That's going to be our purple line. And now we do the same thing for the other one. So we have our start at 0, -1. We do have a positive slope. That means we're going up 1 into the right 4. So let's start at -1. Up 1, 1, 2, 3, 4. Up 1, 1, 2, 3, 4. Up 1, 1, 2, 3, 4. Okay, and now the other way. Down 1, 1, 2, 3, 4. Good. Down 1, 1, 2, 3, 4. Down 1, 1, 2, 3, 4. Using your ruler, The trick is to place your ruler a little below or a little bit above your points. So that way when you actually are graphing, your pencil could be on the dots. Okay, let's make this one, I don't know, let's make this one pink. And again, what is the answer to what we're doing? Well, the whole point of what we're doing is to find that point of intersection. So we're going to go up from our point of intersection towards our x's. X's always go first. Then we're going to go over to our y's. This is the whole point of what we graphed, to find the point of intersection. So let's write out our answer. Let's do it here. Our x value was -4, and our y value was -2. I am going to skip this last one for C. The only reason I'm going to skip it is it does end up crossing at a very weird section. So I'm going to give you the answer. If you want to try this one, go ahead, but I am going to skip it. The answer for C ends up being a -5/2, comma, -2. Now we can solve this using other methods like elimination substitution. Since it is in the graphing section, it is a poor choice of a graphing question. So I am going to ask you to skip it. If you would like to try to solve this, please do it and check your answer. Okay, let's move on. Next one is asking you to solve the following linear equations by graphing. Now this one, it looks different than what we've been doing so far. In reality, it's actually an easier question than the one that we just did. You've done this already in this packet, even though it looks really different. So we're going to pick up the first section. We're going to pick up that second section, and we're going to separate them with an equals, right? That equals we're going to remove. And then we're going to write this as y equals 3x minus 1. And the other one is going to be its own y equals as -2x plus 4. And that's it. And now you're ready to graph. So we have a start at -1. We're going to go, let's go ahead and write this out. So we have 0, comma, -1. We have a positive slope of 3/1. Positive means we go up and to the right. So we go up 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1 for our first line. Can connect, I'm going to do slightly above my points so my pencil can go through it, and that's going to be our green line. Oops. Okay, now for the yellow, let's go ahead and do our start at 0, 4. This is a negative. So that means our slope of 2/1 is now going down and to the right. So finding our start at 4, down 2, 1, 2, to the right 1, 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2, 1. And now we're going to the other side, 1, 2, 1, 1, 2, 1, 1, 2, 1. Continuing that pattern, pick up your ruler, connect, and going slightly below. Pencil going through. And our line is this one here. Again, what's the point of solving equations like this? Well, it's to find that point of intersection, that x and that y value. This is what we're looking for. Find your x value first, then your y. Your x is here, your y is here. So that means our answer for A, here's our answer box, is going to be 1, 2. Same thing on B. Let's go ahead and separate them out. giving each one a y equals. So we got y equals 1/3, x is in the middle, plus 5. And we got the other one as y equals -2x minus 2. Let's identify our start and our slope. So our start for the pink one is 0,5. We do have a positive slope. That means we're going up and to the right. Start at 5, go up 1, 1, 2, 3, up 1, 1, 2, 3, up 1, 1, 2, 3, up 1, 1, 2, 3. Down 1, 1, 2, 3. Again, when you're going the opposite direction, make sure that you are changing only to keep the pattern, right? You're changing, but the pattern is the same. Connect, and we have our line. Okay, next one, we have a start of 0, -2. We do have a negative slope of 2/1. That means we're going to go down and to the right. Let me back up just a little bit. This one was our pink, so that way I don't lose my color coding. And we're starting at -2. Here's -2. We're going to go down to 1, 2, and to the right 1. 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2, 1, and then the other side. 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2, 1. Hold on a minute. Something seems off. You guys, do you see that? On my pink one, I accidentally made a dot at 6 instead of 5. So I need to correct that, okay? So I'm going to pause here on graphing my purple. I am going to erase. Maybe I should have checked my work before I did my pink line. That's okay. I'm human. Things happen. Not the end of the world. It might be a little bit difficult for me to see though. Let me actually graph this before I erase my pink. Okay, so let's try again. 1, 2, 3, 4, 5. I am redoing the pink. Going up 1, 1, 2, 3, up 1, 1, 2, 3, up 1, 1, 2, 3, up 1, 1, 2, 3. And then 1, 2, 3, down 1, 1, 2, 3. So what messed me up is my start. I accidentally did a start on 6 instead of start on 5, just because the graph. So be careful when you're graphing. Really see your numbers, because definitely this can happen. So let's erase, 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 erase. And that's okay. Things happen. I'm human. All right, let's try again. This is our pink. Connect. There we go. I'm going to highlight that. That's our pink line. Let's go back to our purple. So our purple was 2, 1. So here's 1, 2, 1, 2, 1, 1, 2, 1, 1, 2. There it is. 1, 2, 1, 1, 2, 1, 1, 2, 1. There it is. And again, we're looking for that point of intersection. I am going to give you pretty points of intersection, especially when graphing. Things like the other one that I had you skip with a fraction of a point of intersection, I will not be giving you that on an exam. Fractions and decimals are not allowed, so keep that in mind. But fractions are something that you can see when solving elimination or substitution, not graphing. Graphing, I will only give you pretty values. And so now we have our point of intersection. Finding your x value, finding your y value. Your x, bring that down, is -3. Your y, bring that over, is 4. And again, we want our point of intersection. You can call that your POI. Your answer for B, now that we have corrected ourselves, is -3, 4. Then my apologies for being human. All right, moving on. 5, tell whether the ordered pair is a solution. So this right here is going to be kind of like a English answer. You're going to do mathematical work, and then at the end, you're just going to write an English sentence. So step number 1, identify your point. Look at what they're giving you. They gave you 0 and 4. Label it X and Y. When you write out your inequality, this is an inequality because it has this symbol here. You're going to put in an x value of 0. Here's x, here's 0, a y value of 4. This section right here, you can just type in all in a calculator, bringing down that inequality. So this is not flipping. This is not asking ourselves, do we multiply or divide by a negative number? Nothing. The only thing we're going to see is if this is a true or false statement, which then will give us our English answer. 4, open 0, close it, minus 4 equals negative 4. So calculator, negative 4. And so now we're going to ask ourselves a question. Let me separate this. I'm taking up too much space. Negative 4 is greater than or equal to 5. That's what we're asking ourselves. Is negative 4 greater than or equal to 5? You can also do this on a number line. Here is 0. Here's 5. 1, 2, 3, 4, 5. And here's negative 4. 1, 2, 3, 4. Your smaller numbers are going to be on the left. Your bigger numbers are going to be on the right. So 5 is bigger. Negative 4 is smaller. So is negative 4 bigger to 5? No, this is a false. But false is not your answer, okay? This is just, is this true? Well, no, that's not true. The answer is no, open, 0, 4 is not a solution. So to put this in an answer box, this is what it would look like. Okay, false is not the answer. False is part of your work. Let's try again. Identify your point. Here's your point. Label it X and Y. Open up for X. Open up for Y. Put in your X. What's our X value? 5. Put in your Y. What's our Y value? Negative 7. Type this into the calculator. Negative 2. Open 5. Close it. Minus 3. Open. Negative 7. Close it. And we get 11. So calculator, 11 and 15. Let's go and translate this. 11 is less than 15. And again, you can check yourself on a number line. So here's 0, here's 11, here's 15, here's your bigger side, here's your smaller side. So 11 is closer here on the smaller side, 15 is on the bigger side. So is 11 smaller? Yes, this is true. And again, true is not your answer. If you give me true or false, that will not give you any credit because that's not what we're asking. We're asking, is something a solution? So your answer is going to be now yes. Open 5, comma, negative 7 is a solution. So when you're testing, you want an English sentence as your answer. All of this math that we did, that's just your work. Let's go ahead and move on. Next one, we are graphing the one variable equation. We know this is an equation because we are, oh, there's a typo in here. So it says graph the following linear inequality. Okay, I gave you an equals. Let's go ahead and fix that, please. For this one, we're going to fix it as a greater than or equal to symbol. And this one, let's just go ahead and erase all of it. I guess just the equals. We're going to change that into a less than. So we have two fixes here, two typos. We're going to fix that symbol and we're going to fix that symbol. Okay, so we are graphing one variable inequalities. Okay, and we got to make sure to shade in the true region. Please make sure to have colors. You can use highlighters, you can use colored pencils, etc. So now we are going to find 3 on y. We only have one letter, so we're going to find the number 3. 1, 2, 3 on y. And because we only have one variable, we are going to create either a vertical or horizontal line. Next, we are going to identify, is it going to be solid or dotted? Because of this line here underneath, this is going to be a solid line. If I go and look at my point and I do a vertical line up and down, notice that I'm going to be on the y-axis. That's not creating a line, that's just copying down a line that's already there. So we need to create a line going through, crossing out the number 3. So here's my line. It is solid. And you want to extend this past. Okay. Now we're going to create a testing point. Usually our testing point is 0, 0, just because it's easier to work with those numbers. Label your testing point as x comma y. We have y is greater or equal to 3. I'm going to remove y. I'm going to open for y, and I'm going to put in my y value of 0. And I'm going to ask myself, is this a true or a false statement? If you need to use a number line, that's fine. 0 is bigger than 3. This is false. So that means all of this section here is going to be your false section. And we are going to shade in, color in the other side, which is true. Make sure that when you are coloring in, shading in, you are not touching the line, and that your colors shading in is very neat. Scribbles will not be accepted. Let's try again. Now on this side here, we're going to find -5 on x. So here's x. Where's -5? Let me try, because last time 1, 2, 3, 4, 5, I messed up with my 5. Here's 5. Ask yourself, is this going to be solid or dotted? Notice that this line, this little bottom symbol, is not there. So this is going to be a dotted line or dashed. Pick up your ruler. You have two options. We have one variable, so it's either going to be a horizontal line, which there is a horizontal line already, so it's not that one, or a vertical line, which this is going to be. We want a dashed line. Extend it past. And we want our testing point of 0, 0. So testing point, open up for x. 0 is smaller than -5. Here's a little number line. Here's 0. Here's -5. Here's your smaller side. Here's your bigger side. 0 is bigger. -5 is smaller. So is 0 less than -5? Well, no, 0 is bigger. So that means this is false. So everything in this section here, I'm going to turn my paper. This is going to be also false. This is not true. And because all of this section is false, I'm going to color in my other side. Do not touch your dotted line. Make this nice and neat. And the other section would be our true section. All right, moving on. Now, going from here where we had only one letters, we had an X on B, we had a Y on A. In number 7, we actually have 2 letters in one equation. So this is your standard form. This is your slope-intercept form that we need to create. So let's go ahead into graph. I'm going to create this into your y equals mx plus b format, your slope-intercept. I'm going to put that in a thinking bubble. Let's make these into y equals so it'd be easier to graph. So we have a adding x to both sides, dotted line for balance. We get 2y, positive x plus 2. Again, divide every single thing by 2. Y is equal to, we're coming across that same situation we had before, where we have an x on top that we're moving to the side. So we're asking ourselves, how many x's do we have? And we have 1 x's here. So be careful on that. So here's our equation. Not equation. That's wrong. This is an inequality. But in order to know the sign for the inequality, this is where you have to here ask yourself a question. Did we multiply or divide by a negative number? So I'm looking at these two. This is a divided by a positive. So when we bring down our inequality, we're going to keep the same inequality. There is no flip. Only flip the inequality when you have a negative that you are multiplying or dividing by here. Not when you are testing solutions. This is not a test for solutions. This is a graphing situation. So let's go ahead and start. So we're going to start at 0, positive 1. We do have a positive slope. So that means I'm going to go up and to the right. Switching to pencil, let's find positive 1 on the y. I'm going to go up 1 over 2, up 1 over 2, up 1 over 2, and etc. Down 1 over 2. Okay. Just one line graphing. We're not looking for any sort of intersections. And before I even graph, I'm going to quickly look at my inequality sign, not the original, but here. When I look at my inequality sign, that's going to tell me if it's going to be open or closed in chapter 2, or in chapter 5, it's going to tell me solid or dashed. So this is going to be a dashed or dotted line. And because I don't have that symbol underneath that line, underneath my inequality, that or equals to, I'm going to do a dashed line. Sometimes I say dotted, but I really mean dashed. Arrows are still required. This is still a line. And then we got to do our testing point. Okay, so testing point, we usually go with 0, 0 when it's available. So it's almost not available just because it's super duper close to the line that we graphed, but that's okay. We can still make it work. So here's our testing point. It's still under. And I'm slightly running out of space, but that's okay. Let's see if we can make it work. Testing point, where can I write this? I'm just going to write this on the back side of something. So our testing point, you can either use this one here that we created, or you can use the original. That part doesn't matter. Usually I use the one that we've created. Open up for X and open up for Y. Our test point is going to be 0, 0. That means X is 0, Y is 0. I'm going to put in 0, 0 here. 0 is greater than. You can use a calculator if you want. If you are using a calculator, this 1/2 must be in parentheses. Otherwise, the calculator will lie to you. And this is going to be removed because we're multiplying by 0. We have a positive 1. The question is 0 bigger than 1? If you're not sure, here's 0, here's 1, here's your bigger side, here's your smaller side. 0 is smaller, 1 is bigger. So is 0 greater than 1? No, this is false. So because we have our testing point in the false section, here's false. We are shading in the other side for our true. Again, we want this nice and neat. And again, the shaded in is going to be our true. And then the other side is going to be our false because our testing point gave us a false section. All right, let's go again. B. For B, we're going to start off the same. We're going to write this out as slope intercept form, dotted line. We're going to add 9x to both sides. Bring down the positive 3 times y. Here we have positive 9x plus 3. We're going to divide by 3 positive on every single 3. Every single thing. So we have y, 9 divided by 3, dotted line. 9 divided by 3, both positive is 3, x. 3 divided by 3, both positive is 1. Now we ask ourselves that question, did I multiply or divide by a negative number? And here we divided by a positive. Since we divided by a positive, when we bring down that inequality sign, we're going to keep it the same. Here is the inequality that we're going to be graphing. Our starting is going to be at positive 1. We do have a positive slope. So that means we're going to be going 3 up and 1 to the right. Let's go ahead and graph, starting at 1. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. The other side, 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. Let's take a look. Is this going to be solid or is this going to be dotted? Looking at our inequality symbol, notice that there is that line right there, so it's going to be solid. With the solid line, here it is, and we do our testing point. Again, this one's kind of really close to the 0, 0. So choose a different number. It's not, again, this one makes me very uncomfortable on that one. So don't choose 0, 1. So I'm going to choose something, I don't know, something that's a little bit on the random side. I'm going to choose -1. I don't know. Let's do -1 and 4. Somewhere here. So I chose a random testing point at -1 and 4. Again, I'm using this other sheet of paper for my testing sections, just because I'm writing big. Okay, so I'm going to use the y is greater than or equal to 3x plus 1, where my testing point is -1 comma 4. Label it x and y. Open up for y. Open up for x, put in your y of 4, put in your x of -1. Type this into the calculator. Again, this is not going to be 0. It could be, not to say that it won't, but this is not like the other where we get to use zeros. 3, open -1, close it, plus 1, and I get -2. And again, we're asking ourselves the question, is this true or false? Is 4 greater than -2? Use a number line if you need to. Here's 0, 1, 2, 3, 4 is bigger. 1, 2, -2 is smaller. So is 4 bigger? Yes, this is true. So because our testing region, our testing point is true, we are going to be shading in that true region where our test point is in. Okay, that means on the other side, this is all of our false section. Okay, moving on. Let me actually take my other sheet of paper so I don't lose that. And moving on. C. Now this one's still asking us the same directions, which is graphing and shading in that true region. So let's go ahead and one more time, solve for y. Dotted line, subtracting 5x, subtracting 5x. We get 10 times y, positive 10, bring down the plus. Here we got -5x plus 40. Divide every single thing by this positive 10. Y something, right? -5 positive 10, we get -1/2 x. 40 divided by 10 is positive 4. Now again, we are asking ourselves that question, did we multiply or divide by a negative number? So here's 10, here's 10, here's 10, and we divided by a positive. So when we divide by a positive, we are going to keep our inequality sign the same. So y, bring down the inequality symbol the way that it is. We get negative 1/2 x plus 4. Now that is what we're going to be graphing. We do need to determine if this is going to be a solid or a dotted line. Looking at our inequality symbol, notice there is no line underneath it, so that means this is going to be dotted or dashed. Let's go ahead and look at our start. Our start is going to be at 0, 4. We do have a negative slope. That means we're going to be going down into the right. So let's go 1, 2, 3, 4, down 1 over 2, down 1 over 2, 1, 1, 2, 1, 1, 2, 1, 1, 2, down 1 to the right 2. Now other side, so up 1 to the left 2, up 1 to the left 2, up 1 to the left. Oops, up 1 to the left 2. There it is. And we said this is going to be a dotted dashed line. Oops. So let's go ahead and put our ruler slightly under dotted dash. So dashed. Make sure you extend past the giving, x and y. And then we do our testing point. So for our testing point, we are going to, again, I'm using my separate sheet of paper for our testing point. This one, 0, 0 is available to us. And we're going to copy down. Now, again, you have a choice. You can either use the original C or you can use the one that you created. It is up to you. I'm going to choose to use the one that we created. So we have y is less than negative 1/2 x plus 4. My testing point is 0, 0. So that means 0 was x and 0 was y. Open up for y, open up for x, and because these are zeros, we can just cross this out and we have 4. So again, if you need a number line, go ahead. Here's your bigger side, here's your smaller. Is 0 less than 4? Well, yeah. 4 is bigger, 0 is smaller. So yes, this is true. So because this testing point is true, we're going to color in that true region. And again, when you color in, please make sure that you do this neatly. Don't scribble. And on the other side, all of this is going to be false. And when you're writing the word false, don't touch that line. Okay, moving on. Question number 8. Question number 8 is tell whether the ordered pair is a solution. So for each one of these, there's a little line here in the middle. You're going to I'm going to recommend that we write small on this one. Okay, so I need to write really small and then leave some space for the answer. Create a t-chart. Then you're going to copy down your equation. I'm kind of doing both at the same time, but that's okay. These are inequalities, not equations. Let me make that correction. Inequalities. Label your point as x and y. Okay, so now that I've kind of identified some things, let's go ahead and do one at a time. So I'm not doing B, I'm doing A. Y is greater or equal to 3x plus 1. Y is greater than x minus 1. You're going to open up for y. You're going to open up for x. You're going to open up for y. You're going to open up for x. You're going to put in your y of 4. You're going to put in your x of 1. This section right here can be a calculator. Bring down the 4. And all you're doing is you're asking, is this going to be true or false? And then writing out your English answer, kind of how we did earlier. So right now, I'm not really asking myself anything. I'm just bringing it down using a calculator. 1 minus 1 is 0. Okay, so let's ask yourself a question. Is this true or false? 4 is bigger than 4. Well, no, 4 is not bigger than 4. Is 4 equal to 4? Yes. So this here is true. Is 4 bigger than 0? Yes, that is also true. So when you have two truths, and only when you have two truths, if one of them is false, this does not work. Only when you have true, you can say your answer. Yes, 1 comma 4 is a solution. So again, let's box our answer. Boxing our answer. Next, same thing here. Copy down the purple, copy down the pink. Y is less than or equal to negative x plus 1. Y is less than or equal to 5x minus 2. Open up for y. Careful with the negative. You're opening up for x. The negative is on the outside of the parentheses. Putting in the x and the y. So y was negative 3. X was 4. Alrighty, bring down the negative 3, less than or equal to, type this into the calculator. Now, when you type this into the calculator, be careful. You're going to use this negative button down here, down below, negative. Then you're going to open for close it, plus 1. So it should look the same exact how you have it with the parentheses. And this is negative 3. Here, copy it down. And we get 5, open 4, close it, minus 2, 18. And we ask ourselves the question, is this true or false? Is negative 3 smaller than negative 3? No. But is negative 3 equal to negative 3? Yes, this is true. Is negative 3 smaller than 18? Yes, negative 3 is a negative number. 18 is a big positive. So yeah, that's true. And when you have two truths, and only when you have two truths, yes, our point of 4 comma negative 3 is a solution. Alrighty, beautiful people. We are not done. I am going to pause here to take a break. This video is a little bit on the longer side. When I come back in a very short while, we're going to continue with number 9. All right, let's go ahead and continue. Question number 9 is graph the following systems of linear inequalities. Reminder, make sure to shade in the true region. All right. So in class, we worked with some patty paper. We did the first inequality shaded. We did the second inequality shaded. We copied them on patty paper, and then we took our information and graphed the system. This is not one of those cases. So I'm going to show you in this video another way to find out what the true region is in an inequality. So step number 1, we're going to graph this line. Now, this is one variable. We can see that we have just y here. We don't have an x. So that means on the y, I'm going to find a negative 1. Now, because we have one variable, this means that we're going to have either a vertical or a horizontal line. And that line, because I see this or equals to, is going to be a solid line. So I'm going to bring my ruler, and if I have a vertical line, notice it's going to be on the y-axis. So our y line is not a vertical, it is a horizontal line. So let me go ahead and adjust my camera here so you guys can see a little bit better. There you go. And what did we call it? We called it a solid line. So I'm going to do a solid line. Put your rulers below your point and arrows. Okay, don't shade in yet. We still don't want to shade anything. Next, we have our other line, which is the 2 variable. Okay, this is your slope intercept. So that means I have my slope as negative 1 over 1, and I have my starting y-intercept as 0, 2, positive 2. So I'm going to find 2. Here it is. And I have a negative slope, so I'm going to go down 1 and then to the right 1. But before I do that, I need to determine, is this line going to be solid or dotted, dashed? Since I do not have the or equals, this is going to be a dashed line, or you can call it dotted, but I do want you to draw actual dashes. So I'm going to go down 1 and to the right 1. Down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. And we continue here. Let's see if I can actually see. Be careful when graphing these. Unfortunately, the printer we have didn't make these dark enough, in my opinion. Okay. What did we say? We said this was dash. So I'm going to put my ruler a little bit below my points, and then I'm going to dash the line. Now remember, these are lines, so I do expect to see arrows. Let me shift that up a little bit. On both sides of your lines, on all of your lines. Lines, by definition, need arrows. Okay, so now we have these sections, okay? I'm going to call this section right here section 1, section 2, section 3, and section 4. One of these sections is going to be a true section, okay? So we can use the same method that we did before when we are doing just regular inequalities for your testing point. So I have another sheet of paper here. I am going to copy down my inequalities, both of them. So this is 9a. I have y is greater or equal to -1. I have y is less than negative x plus 2. And I am going to create a testing point you can do in each section, or you can get lucky and have a true situation. But what we're looking for is we're looking for true in our first inequality and a true in our second inequality. One of these is going to be false, false. One of these is going to be true, false, or false, true. And then one of these is going to be true, true. So I'm going to, let's start with 1. I'm going to choose a testing point. I don't know. Let's say we got 4 and 1, 2, 3, 4, 5. So this testing point is going to be at x is 4 and y is 5. I'm going to bring that here. And just like we did before, I'm going to test if my testing point of 4, 5 is a true situation. So I'm going to copy this down. I'm going to say y. Oops, let's not put y. Let's go ahead and open for y. We already know what y is. Open for y. Here I need to open for y and open for x. Be careful with that negative. It is outside the parentheses. Our y is 5. And our x is 4. Again, what's the point of what I'm doing? Well, the point of what I'm doing is to determine if we have a true or false situation. Is 4, 5 an answer to this inequality? Yes or no? Is 4, 5 an answer to this inequality? Yes or no? Okay, so is 5 bigger than -1? So if you're not sure, you can use a number line. Here's 0. Here's 1, 2, 3, 4, 5. 5 is bigger. Here's -1. -1 is smaller. So this is yes, this is true. Here we have 5, so let's bring that down. -4 plus 2. -4 plus 2 is a -2. And again, is this a true or false statement? Here's 0, here's 1, 2, negative. That means -2 is smaller. 1, 2, 3, 4, 5 is bigger. Here we're reading, is 5 smaller than -2? Well, no, that's a false. Because we have a true false situation, no, 4, 5 is not a solution. So that means here in this section, in this right here, this V, all of this is false. Okay, so this does not work. So instead of writing false, I'm just going to erase my testing point. I'm going to remove it, and I'm going to leave that section empty. I will do that in a little bit. I'm going to move on to my next V here, and I'm going to choose a point, let's say -7 and 1, 2, 3, and 4. -7 and +4 is in section 2. So our next point, testing point, we said is going to be -7, +4. And I'm going to try this again. and see what that is. Is that going to give me a true, true, false, false, true, false, what that is? All right, let's write out our inequality. So we still have y is greater or equal to -1 here, and we have y less than negative x plus 2. Again, label your point x and y, which we already did, and open for y, and open for x. Make sure that negative is in front of the open, in front of the parentheses, not inside. Alrighty, what was our x value? X is -7. What was our y value? Y value is 4. So, is 4 bigger or equal to -1? Again, use a number line if you need to. Here's 0, here's -1. It's smaller. 1, 2, 3, 4 is bigger. So, is 4 bigger than -1? Yes, this is true. Bring down the 4, negative, give you a positive 7 plus 2. 4 is smaller than 7, 8, 9. Is 4 smaller than 9? Yes, that is also true. So because we get true and true, that's what we're after. We want true, true. That means yes, -7, 4 is a solution to the system. Now, this right here is just our work. We have to go back into this true section, and we're only going to color in that true section. Let me get 2 colors. So that means that I'm going to have only the color section here. And again, we have 2 lines, so I'm using 2 colors. Be careful on your shading. So only this section is colored in. So this testing point was false. So I'm going to remove this other testing point. Now, I do not need to test my 3 and my 4 regions because I already got my answer. I already got true and true. So if you start testing here, this is going to be false, and this is going to be false, or at least one of them will be. So only shade in the true, true, and if you happen to get that on your first guess, fantastic. If you happen to get that on your last guess and you have to do this a couple times, that's also okay, just will take more time. All right, let's go ahead and try this again. Let me actually grab more paper off screen. All right, let's go ahead and do the same thing. So let's go ahead and graph. So if you notice on this one's a little bit different. This is not in your slope-intercept form. This is in standard form. And because it's in standard form, we do need to rewrite this into a intercept form in order to graph. So I'm going to pick up my first inequality, and I'm going to solve for y. Now, solving for y here, we're just going to subtract 2x on both sides. Here, because we are moving things around, this is not checking for solutions. This is rearranging. We do need to ask ourselves, did I multiply or divide by a negative number? Well, no, I didn't multiply and I didn't divide by anything. So that means when we bring down our inequality, we keep it the same. Let me go ahead and put this in a gold thinking bubble because these inequalities are the same. So that means we start at -1. We are going to go down because it's negative 2 over 1. And this is going to be a dotted line. So down 2, 1, 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Up 2 over 1, 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 up 2 over 1. And what did we say? Is this going to be solid or dotted? It's going to be dotted because we don't have dash, technically. We don't have an or equals to. We don't see a solid line, so we don't do a solid line. Dotted, 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 dotted. Arrows are required. Again, this is a system, so no shading yet. We're going to go into our second inequality. We got to do the same thing here, and we got to make it into a y equals, I guess not an equals, but a slope-intercept form. So 2x plus y is greater than 3. We are again subtracting by 2x here, bringing down the y, negative 2x plus 3. And again, we ask ourselves, did we multiply by a negative number? If we did, we have to flip the inequality. So here I'm looking, and again, we did not do any multiplying or dividing by anything, so we're going to keep our inequality sign, and this is what we're going to graph. So we have 3 positive, so let's find positive 3. And again, going down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Ooh, I'm noticing something. Alrighty, I feel like we have to have a discussion about what's happening. So it looks like we have parallel lines. This is also going to be dotted. There is no symbol there. However, this is not an equation. These are not equations. These are inequalities. The answer to an inequality, and especially a system inequality, is a color shading, okay? So even though, yes, you're absolutely right, there are no intersections here. We really don't care about the intersections. These lines don't have to touch. We still have to color in the true region. So that means we still have to either use patty paper or we have to use our testing points. So that means we're going to be testing this section here. I'm going to call it 1. We're going to be testing this section here inside, in between your 2 lines. That little tiny section needs also a test. And section number 3 also needs a test. So that means we're going to be testing potentially 3 points. If we get lucky with number 1, fantastic. So here's my other paper. And we're going to be testing a point. Let's do region number 1. Let me actually copy down my inequality. Now, notice how I'm writing the original here. You can put in your testing points into the original, or you can put your testing points into the ones that you have created. It really doesn't matter. Whichever ones you want to put in your testing point, that's fine. So we got y is less than negative 2x minus 1 here. Y is greater than negative 2x plus 3. Just because I wrote those down last, and only because I wrote those down last, I'm going to use these ones here. Y is less than negative 2x plus, just kidding, minus 1. And y is greater than negative 2x plus 3. Testing point in this region here, region 1. I'm going to do, let's say 6 and 1, 2, 3. 6 and 3 is going to be my testing point for region number 1. Here's my x, here's my y. Let's go and open up for y, open up for x, open up for y, open up for x. Put in our y of 3, put in our x of 6. Now again, you can use a calculator on this. This is a checking your solution. So do not do any flipping of any signs. All you're going to do is bring things down, like the 3, the y, pick up a calculator, negative 2, open 6, close it, negative 1, and I get negative 13 here. And all you're going to do is type it into the calculator exactly how you see it. Please do not flip anything around. Okay, let's check the first one. The first one we are checking is going to be a 3 is less than negative 13. Is this true or is this false? Well, let's take a look. Here's 0. Here's 1, 2, 3. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 negatives. So 13 negatives is smaller, 3 is bigger. So that means, is 3 smaller than negative 13? No, that's a false. Okay, what about this one here? Is 3 bigger than a negative 9? Let's see. Here's 0, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's smaller, here's bigger. So 3 is bigger, negative 9 is smaller. So that means this is, oh, just kidding. This is true. Okay, moving on. This is true, false. So this section here is going to be, oh, let me move the camera here. This section here is false. Okay, what we're looking for is a true, true. If we can get a true, true, then we are good. Moving on to a next. So let's go ahead and test this 2. Middle region. So we have to be careful here on finding points that's in between. So I'm going to do negative 2 and 1, 2, 3, 4, and this is what? Hold on. 1, 2, 3, 4, 5. So I'm going to do negative 2 and 5 for my next point. So it's going to be here. Testing second point. Oops. Negative 2 comma positive 5. Here's our x, here's our y. So y is less than negative 2x minus 1. Y is greater than negative 2x plus 3. And we're going to open for y, open for x, open for y, open for x. Our y is 5. Our x is negative 2. Again, don't do any flipping here. All we're doing is checking for a true and a false. Typing this into the calculator, we got negative 2. Oops. Negative 2, open negative 2, close it, minus 1. I get 3. We get negative 2, open negative 2, close it, plus 3. Oops, plus 3. Alrighty. So is 5 smaller than 3? Well, no. 5 is not smaller than 3. False. Is 5 bigger than 7? Well, no, 5 is not bigger than 7. So this is also a false false. So second region in the middle is also false. I'm not going to write it, it's too small, but we're going to move on to our third testing region. And I'm going to find a point, I don't know, let's do negative 8 and whatever this is, negative 8 and negative 4. And again, we do our little setup. Sometimes it is unfortunate that the first one you select is not the answer, because sometimes if it is, then we can get this done quicker. Open for y. Open for x. Here's x, here's y. Our x is negative 8. Oops, I need to open for x. And what was it? Negative 8. And then here we are. And then we have, what do we have here? Y is negative 4. Okay, so we got negative 4. Bring that down. Calculator this. We got 15. Bring that down. Alrighty, let's take a look here. So we got -4 is less than 15. Is that true? Well, if you're not sure, you still, again, can use the number line. Here's -4. Here's +15. 15 is bigger. -4 is smaller. This is -4 smaller than 15? Yes, that is true. Now we're looking at -4 is greater than 19. Okay, so again, where's 19? Where's -4? -4 is here, meaning it is smaller. 19 is here, meaning it is bigger. So is -4 bigger than 19? No, this is false. So take a look at all of our work. We have a true false, we have a false false, we have a true false. When this happens and you do not get any true true, okay, if you do not get any true situations, that means then you have a no solution. So there are going to be no coloring on any of this here. So I'm going to actually go in, write an F here in the middle. Oops, there it is. And then we can write false here as well. It is okay to leave it completely blank and not write false. You still have to graph your lines, but no coloring here. If you do end up with the true true, you must shade it. But if we end up with the false true, false false, true false, that means no colors are going to be included. Okay, moving on to the next one. I am pretty happy about this one here because it is in slope-intercept form. It looks like I have enough space on here to test my points. So we'll see what happens. Maybe I'll use another sheet of paper. Let's go ahead and graph this one here on top. This is in slope-intercept form, so I'm finding a -3. I have a +2 as my slope, so +2 over 1, +2 over 1. So that means I'm going up 2 jumps over 1, 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 down 2 over 1, down 2 over 1, down 2 over 1. Solid or dotted, let's take a look. There is no line there, so that means we are going to be dashed here. Make sure you extend it and give me arrows. And then we have our next one. Again, we are in slope-intercept form. Mx plus b is what I see, so we're going to start at +1. I do have a slope that is increasing 1/2, so that means I'm going to go up 1 and to the right 2. Up 1, 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 to the right 2. Like that, and then down 1 to the right 2. Hold on, I'm starting at the wrong spots. Down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. So it still should be increasing. Just my slope is slightly different. Let's go ahead and graph. Is this solid or dotted? This is going to be solid. We do see that or equals to length. So this is what we create. And then we have our regions. We have 1, 2, region 3, and region 4. I do have some space here. So I'm going to test one of my points. Again, what we're looking for is a true situation. I'm going to randomly choose a section in 2 just because it's closer. You can start with 1, 2, 3, 4, but you can also just go out of order. Whatever your heart desires, you're just looking for that true. So I'm going to create a testing point of, let's see, let's do -8 and 5. And again, this is a random -8, 1, 2, 3, 4, 5. This is a random testing point just because it's in that region. Open up for y. Open up for y and x. Now, if we are using a calculator here and not our brain, that 1/2 on the other side needs to be a fraction inside parentheses inside our calculator. So 5 is our y, and negative 8 is our x. I'll show you what I mean by the calculator. This does not have any fractions, so we can just type in 2, open negative 8, close it, minus 3. Okay, I get a negative 19. Here on the other side, I do have a fraction. So when you type this into the calculator, that 1/2 needs to be inside parentheses. If you don't do this, the calculator will give you a wrong answer. And I get a negative 3. So again, true or false? 5 is bigger than a negative 19. If you're not sure, here's your number line. Here's 0. Here's 5. On the bigger side, here's negative 19. On the smaller side. So yes, this is true. All right, 5 is bigger than negative 3. Here's 0. Here's a negative 3 on the smaller side. Here's 5 on the bigger side. This is also true. We got lucky. So we got true, true. So this region right here is going to be shaded. All of that region, be careful, don't touch the actual lines. And typically we'd like to see 2 colors for each line. So 2 colors, 2 lines. There it is. For our true region. I don't need to test the other ones because I already know what the answer is, and everything else would not give me a true true. Only one section is going to give me a true true. All right, let's go ahead and move on. I believe this is it. All right, beautiful people. That was unexpected. Enjoy the rest of your day, and I will see you in our next video. Bye.